Well, hello, it's Cliff here, toolmaker from Down Under. In this video I'm going to go through making another part on Threadexpress, demonstrating some more of its abilities. It is a flanged nut and there's going to be some internal thread milling and some indexing milling the hexagon on the flange nut. If you're not familiar with Threadexpress, have a look at some recent videos that demonstrate what it can do. I'll probably run a little clip briefly to show you what it can do. It's an attachment for a milling machine that allows you to cut a wide variety of threads through the process of thread milling, and also has an indexing facility inside it as well that turns it into a rotary table indexing head. I'm having a real bad week this week and I made a stupid mistake making this part, and I think I'll leave it in there for a bit of light entertainment for you guys. So this video I'm going to do a machining operation in Threadexpress of a special flange nut to replace this nut shown on the tool posts on this lathe. So it used to have one of these permanently attached handle type of nuts, but I found it got in the way for certain setups, and so I temporarily put on a standard nut and a thick washer, and it's been like that for years, but it's a little bit rough and ready. So I've just machined up a 01 steel blank, and I'm going to thread mill the thread and cut the hexagon on Threadexpress. There's my little drawing there showing the part, and I'll be machining the internal thread and hexagon. Now obviously I could just use a tap, but I'm using this as an example of a thread that might be an unusual thread. You know, it may be a special piece of equipment that a tap isn't readily available for, a piece of vintage car nut or some problem thread, or it may be just that you don't have access to a large tap in the time frame that you need to cut this thread, and so Threadexpress is ideal in those situations. Once you get to big threads, taps become quite expensive. High-speed steel taps become quite expensive, and Threadexpress makes more and more sense. For very small threads, thread milling is not so ideal because the cutter becomes more and more small and fragile. Well, this example to demonstrate thread milling is just a standard 16mm thread, 2mm pitch, but it's just an example. I would assume you'd use this machining operation for an unusual thread where a tap is not readily available. I do have one in this case, but I'm using it as an example. So with external threads, you've probably seen me use larger fly cutters. For internal threads, you need a much smaller cutter, obviously. Let's grab a nut as an example. So obviously you've got a much smaller cutter. Now you can buy cutters. I have bought one. Horror of horrors, they're quite expensive, and I haven't used it, but I just wanted to have one as an example. I've cut my own internal multi-tooth cutters out of old carbide end mills, but I think generally speaking a fly cutter is better because with one tooth you can more readily lap it, sharpen it and modify it and not have to have all the teeth concentric. So this is a little fly cutter with an insertable tooth, has a plunger going right down the length of it with a grub screw on the end, and that allows you to adjust the little insert out various amounts. There's a smaller one here again with a plunger down the middle, pushed by a grub screw, the very small insert there. Also I've ground them out of the solid, out of old end mills, just a single tooth fly cutter type of cutter, very versatile. So I won't go into that in great depth. I've put out, or I will be putting out, a video especially on thread milling cutters, but this is just an overview. So for this one I'm going to use this 7mm shank, hardened shank cutter, fly cutter holder, and I'll be setting it over at the helix angle so that the cutter stays in the valley of the thread. The trajectory of the cutter as the cutter rotates ideally should stay in the valley of the thread. I've mentioned this in other videos, you're probably yawning already as I speak, but if you don't set the helix angle, for example when you're doing CNC interpolating thread milling, then you get errors in the thread profile depending on different variables. There'll be different errors, so it's ideal if you can set the helix angle over and get an accurate thread. It wouldn't really matter for this situation because it's only a simple fastener, but if it's a critical situation it's often necessary to set the helix angle of the cutter over so that you cut a correct profile thread. So I'll set it up now with this little fly cutter and go through cutting the thread with you. So I've got the part in the Threadexpress's 3-jaw chuck. Now I'm ready to mill the thread and cut the hexagon. We've loosened off our turret bolts and we're just going to push that over into the correct position and tighten up our turret bolts, and we're ready to go with that. So first off I'm putting the blank in the 3-jaw chuck and dialing it in concentric. I nearly always do this with my 3 jaws, is have them what I call floating on their back plate and just nip the screws and then just tap it with a bit of copper and rotate it until it is concentric and then tighten up the screws. It only takes a few seconds once you get into the swing of it, and that way you can be sure that your 3-jaw chuck is always accurately concentric, even if it's a cheap Chinese 3-jaw chuck. So in order to find the helix angle of your thread, you can find charts online of helix angles or look on Machinery Handbook. For example, this M16 thread with a 2mm pitch has a 2° 29' helix angle, or you can measure just directly off your thread with a protractor. It doesn't have to be highly accurate. As long as you're reasonably close, there's a bit of forgiveness with the V form of the cutter as it clears the circular form of the part. But you generally do need to set a helix angle rather than have none at all, or you will start to introduce errors into your thread profile. So I've just graduated some lines there, 1° lines, so you can set it approximately right, just over 2 degrees. You can see that's quite a dramatic angle, even 2 degrees. So obviously you tip it to the left or the right, depending on whether you're cutting on the front or the back of the thread. The helix angle is in the opposite direction. I fitted little sliding pointers here on the vertical slide of Threadexpress. You can see those little dovetail adjustable pointers. There's 3 of them there. The middle one shows the middle position of the ratio arm when it's at right angles to the spindle. I've just got a temporary white line there showing that position. The top one shows an adjustable position when the slide is right down as far as you want to go, and the bottom one shows an adjustable position when the slide is right up as far as you want to go. And that's very helpful, I've found, with the trials I've been doing in recent months to help you navigate where you're going, coming up to shoulders, or for internal thread milling when you can't see where you are. Sure, it's got the graduated degrees on the outside, which is good for very fine movements, but for large amounts of movement, when the cutter's whirling round and it's just a blur and you're coming up to a shoulder, it's helpful to have an approximate position telling you where you are so that you can come up to it smoothly and, for example, just look at the dial for the last few degrees. So I've been building these little improvements onto Threadexpress just to make it easier to use. I've got the slideway clamp lock now there in the form of a resettable handle. So for example, with internal threads, I've got the cutter there in the middle of the length of cut, and I've got the pointer showing the middle position there, and that's when the ratio arm is in its middle position. It's down in there, I'm not sure if you can see it. I've also got the pitch set to 2 millimeters pitch there. So that's the central position, and the pointers show the three positions: the mid position, the high position and the low position of that internal thread. So I start it when the cutter's out of the nut, when the work is fully down, and I cut up to that line on the bottom pointer, and that just helps me navigate where I am with that internal thread. Well, I'm machining tough steel, 01 steel, tool steel, and that cutter shank is a little bit light. It's 7 millimeters, but the next one up that I have is 12 millimeters, which is too big. I need to make one about 9 or 10 millimeters diameter, a mid-sized fly cutter shank. So it's quite a big ask. I'm not sure how big a cutter I should take. Probably fly cutter does, multiple cuts does mean a fairly light cutting force compared with single point screw cutting, but still this is a big ask. I'll probably try a 1 millimeter cut. I've got to go in about 1.2, and then a finishing cut of about 0.2 and see how that goes. So I'll probably be speeding it up because there's not much to watch, so I won't be talking, otherwise sped up me will sound like Mickey Mouse. Oh, there's an invitation for a smart comment. Yeah, that was quite hard work for that little cutter. It looks okay. Yeah. I chickened out and only put a 0.9 cut on. So next time I will go a bit further. I might offset it in the Z as well, so I'm only cutting on one of the flanks of the thread. So if I go from 0.9 to 1.1, maybe 1.2, because it looks like a fair way to go. That's another 0.3, and I'll offset it on the vertical by half that amount, 0.15. So it sticks mainly to cutting on one flank. So we'll keep going now. Back on again. Well, I'll blow the swath out with compressed air and have a look at that thread. Not too bad. And the cutter appears to be holding up, but you can really feel it working hard. It's a much more flexible shanked fly cutter than my larger diameter external fly cutters, and that makes a big difference. The small diameter shank on an internal thread milling cutter flexes more and limits your depth of cut. Alright, so how are we going for fit? Well, that's 2 cuts to the theoretical depth of 1.2 millimeters, but that's just an ordinary old bolt. Yeah, that's quite a nice close fit there, because the depth of cut varies depending on, obviously depends on the hole size that you bore out and the size of the flat that you put on the cutter. If you're interested in that subject, I've done a separate video on precision threading where I go into that a little bit more deeply. I better not get down that rabbit hole in this video, or it'll drag on for another half an hour. But it looks like I need to take one more little light cut just to finish it, a couple of thou, and then I should be fine. Well, that was a light cut, taking its full depth down to 1.28. So this is the actual part that I machined years ago when I modified the tool post. It looks like I screw cut it out of a bit of high tensile steel. Yeah, that's a nice fit. So that's good. So now we can get on and do the hexagon machining. This is all quite challenging for a little light indexing head like this, because we're dealing with tough tool steel. But in reality, fasteners are often out of tough steels, because fasteners need to be high tensile, so they are often in high tensile steel or stainless steel, and that's why fly cutting and thread milling is a really good way to machine some profiles of threads. I don't really want to ramble on too much now, but there is a niche of work where this little attachment suits perfectly, and there's other work, for example really big threads, big external threads or very long threads, where you need the power of a center lathe and the torque of a well geared spindle, you know, multiple cuts with the support of a tailstock. That type of machining doesn't suit a thread milling attachment. Obviously the type of work that suits it is small to medium threads, short threads to medium length threads, small diameter to medium diameter threads, internal and external, especially where they're special pitch threads or when you're coming up to a shoulder and so on, because it's just so easy and so quick. It's a very speedy little attachment for those type of threads. So, you know, just having it attached on the end of the milling machine where I can jump on it and cut a thread very quickly is the big advantage for me. I think it's really important when you're cutting high tensile and stainless steel to have high rigidity. It's also really important to use high grade premium cutters. Now you may be able to use high speed steel if it's a high cobalt grade like ASAB 17, but even better if you use tungsten carbide. Not only is it harder, but it allows you to spin the spindle a lot faster, and that means you've got more flywheel action and a smoother cut. You've only got one tooth per revolution, and there's a big advantage in having the high RPM made available by tungsten carbide. And this doesn't have to cost a lot of money. I know some old school engineers may still be using high-speed steel, but in recent years I've been using tungsten carbide more and more. It just allows for a much longer lasting cutter, and you can pick up used cutters from industry, or you'll have a few of your own eventually when your cutters become blunt, and you can get a second use out of those cutters. If you keep them, then you can diamond grind them very easily to the profile that you need for a fly cutter. So if you're not experienced with tungsten carbide and diamond grinding, I'd really encourage you to become involved in that process, because it is just so much more efficient, longer lasting cutters and quicker cutting cutters. So you can just pick up a Chinese diamond grinding wheel, or get one second hand on eBay, pop it on a cheap grinder and freehand grind your fly cutters from old blunt tungsten carbide end mills. And you can buy end mills from China pretty cheaply these days, so it's not a big cost and it's a huge improvement in efficient machining. But if I'm going to suggest people get into diamond grinding of tungsten carbide, I should also check that you're aware that the tungsten carbide dust coming off is toxic and you don't want to breathe it into your lungs. You need an extractor or a mask, or if it's a shortcut, perhaps you can just hold your breath. I do that and breathe away from the grinding if it's only for a few seconds, but don't breathe the dust into your lungs. There is evidence that it can cause some pretty nasty long-term complications, and I just don't think it's worth the risk. Okay, so now we're going to machine the hexagon. So we're going to use it as a rotary table or an indexer. So I disengaged the helical or spiral feed, locked the slide here, and now we can use it as an indexer. So I've got 30-degree positions, so I'll be using every second position to generate the 60-degree hexagon indexes. Well, there we are, all the hexagons are machined, and but you know what I did? I've just had general surgery and they said to me, don't operate heavy machinery. Well, I thought, well, this is light machinery, I'll be alright. But obviously it affects your brain, because on one of the indexes, I only indexed it 30 degrees instead of 60 degrees. Well, how could I do that? It's just crazy. Like, the brain must be disconnected internally by the general anesthetic residue or something. And I got halfway through cutting it and realized, well, that's a pretty interesting looking polygon. Oh God, so there's a little corner missing on this nut now. I should really start again, but I guess it'll work fine. It's just embarrassing. So note to self, don't do any machining after general anesthetic. Wait a few days until it gets out of your system. When they were wheeling me into the operating theatre, I was thinking, well, what size cutter should I use? A big cutter, you know, puts a lot more stress on the work and the spindle, and it's not a heavy duty system. You know, you've got the ram sticking out a fair way there, and it's a fairly light Bridgeport clone machine, and also the Threadexpress indexer itself is reasonably light duty. I can't take massive cuts, you know, I can't put in a 1-inch cutter and cut that flat with one cut. It's just going to jump around. So I thought I'll go for a 6mm cutter. I've got a whole box of old ones. I just got an old 6mm cutter that I'd inherited from industry and ground little chamfers on the corners where the corners are worn off, and did that because I'm machining 01 steel. That's a pretty tough material, and so it's worked out quite well, but you've noticed I've taken quite light cuts and just taken it easy. Did I mention the cutter that I used was tungsten carbide? The advantage of that is you can spin it faster and take light cuts. Oh, I'm brain dead today. Okay, well I guess I am operating heavy machinery now, but it's only for a few seconds and not critical. Oh dear, I'm definitely not 100%, feeling all sort of fuzzy. Anyway, I think that actually parted it off. I think I'm actually observing it happening. Well, let's have a close-up look at it, warts and all. So you can see Threadexpress is great for things like this. Very quick and easy to machine threads and hexagons. I mean, obviously you wouldn't make a standard flange nut in this way, but if it's a special thread or a special size hexagon, it's a quick way to make it. We're machining tough tool steel, so I was able to heat it up very easily and get it glass hard, and then draw it back to a tough temper, a dark brown purple color, which retains a lot of the hardness but also introduces the toughness. So that should be a really good hard wearing nut, but mainly it was an example. Well, let me share with you the satisfaction of putting it back on. So some grease on that thread, and there we go. Oh, wouldn't you know it, the little dodgy corner that I mucked up is right on the front, so every time I look at it, it shows me you've made a stupid mistake. And really, as a contract toolmaker, that's really painful. You know, when you do contract toolmaking, you learn to just not make mistakes. You're working on injection molds and press tools that take weeks of work to make, are worth scores of thousands of dollars, and you can't run a business if you're making mistakes doing that type of work. It's like being a surgeon. You just can't make mistakes, and you have to go slow and triple check everything, and just don't make any mistakes. And I would go for years without making a machining mistake. Of course, that meant that I was slow and cautious. That's the price you pay. But it's particularly painful now that I've made this mistake and it's staring at me and it's forcing me to confront it. I don't know whether I should turn the nut round to the back by grinding a bit off the face and just pretend it didn't happen, or if I should make another one, or if I should keep it to the front and learn to be humble. Well, thanks for watching that video right through to the end. Please remember to like and subscribe if you're not already. If Threadexpress is new to you, have a look at recent videos that I've put together, further explaining its potential or what it can do. Are you aware that Mark Presling also has a YouTube channel, and he is currently building and refining a version 3, and when he's completed we will be releasing plans and technical drawings so that you can build your own Threadexpress.